What is the box and whisker in origin? Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito for you has them all. It's like having a research dream team on demand.
Have you ever stared at a big pile of data and just felt lost? We've all been there. Well, today we're going to pull back the curtain on one of the coolest and most useful tools for making sense of it all, the box plot. Let's dive in and figure out how this thing really works. Okay, so you look at something like this, and at first it might seem a little mysterious, right? It looks really scientific, super precise, and maybe just a tad intimidating. It's packing a ton of information into such a simple little shape. So what on earth is it actually telling us? And that really is the million-dollar question. This isn't just a bunch of random lines in a box, it's a story. It's a full summary of a whole data set. So over the next few minutes, we're going to go from mystery to mastery. You're going to learn how to read this story like a pro. To really get the box plot, you have to understand its DNA. And it all comes down to just 5 key numbers. Seriously, these 5 numbers are the complete blueprint for the entire chart. So it all starts with the basics you'd expect. The lowest value, the minimum, and the highest value, the maximum. Right smack in the middle, you've got the median. That's the exact center point of your data. But the real magic happens with the first and third quartiles. Think of them as the 25% and 75% markers. Together, these 5 numbers slice your entire dataset into 4 perfectly equal chunks. And here's where you see it all come to life. That line in the middle of the box, yep, that's your median. The edges of the box itself, that's Q1 and Q3. This is so cool. It means that a full 50% of all your data points live right inside that box. And those lines sticking out, the whiskers, they just stretch out to your minimum and maximum values. So in one single glance, you see the center, the spread, and the total range. Awesome. But, what about those data points that just don't play by the rules? The weirdly high or oddly low values? This, my friends, is where the box plot shows off its hidden power, spotting the outliers. Let's look at how this works with some hourly temperature data. On the left, you've got a pretty normal set of temperatures. On the right, I've swapped out the lowest and highest numbers for something more extreme, a chilly 52 and a sweltering 89. Now, our eyes can kind of pick those out, sure. But how does a box plot decide, with math, that a point is officially an outlier? Well, the secret is something called the 1.5 times IQR rule. Now, that might sound complicated, but it's not. The IQR, or interquartile range, is just the width of the box, the distance from Q1 to Q3. You take that width, you multiply it by 1.5, and then you use that number to build these sort of invisible fences past the ends of your box. Any data point that jumps over those fences, boom, it's flagged as an outlier. And here's what that looks like. Those outliers we threw in, the 52 and the 89, are now shown as their own separate dots. And look closely at the whiskers. They don't go all the way out to 52 and 89 anymore. Instead, they stop at the last data point that's inside our invisible fence. This gives you a much more honest picture of your data's typical range. Spotting outliers is super useful, for sure, but the box plot's real superpower is comparison. It was literally designed to let you see the differences between different groups instantly. Let's jump back to our water discharge chart to really see this in action. The power here is how fast you can compare these 3 months. Just look at the median lines inside the boxes. You can immediately see that January had the highest median discharge. Now look at the size of the boxes and whiskers. See how January's is way more spread out? That tells you the data was all over the place, while February and March were much more consistent. No need for a big table of numbers, it's just instant visual insight. And hey, for those of you who want to go a little deeper, the standard box plot isn't the end of the story. There are a couple of really clever variations that can give you even more information. 2 of the most common are notched plots and variable width plots. Okay, so notches are a cool little trick. If the notches of 2 different boxes don't overlap, it's a really strong hint that the difference between their medians is the real deal and not just random chance. And with variable width plots, it's simple. A wider box means it was made from more data, so you can literally see which groups have more weight behind them. And the best part is that you don't have to be some kind of coding genius to make these. Just look at this software menu on the right. Creating these more advanced plots, like the ones with notches or different widths, is usually as simple as just checking a couple of boxes. It gives you all the power to customize your charts to tell the most accurate story you can. So let's just bring it all home. A box plot isn't just a chart. It's a really compact summary and an incredibly powerful tool for comparison, all rolled into one. It takes a messy, complex dataset and turns it into a simple, elegant story. So I'll leave you with a question. The next time you see one of these charts in the wild, what's the first story you're going to look for? Are you going to check out the median, the overall spread of the data? Or maybe you'll go on a hunt for those revealing little outliers. Thanks so much for tuning in.
And subscribe now for more amazing videos just like that. Thanks for watching.